Hello again, welcome to my channel. So today we're going to finish the topic of Introduction to Networking Part 1. Okay, and these are the remaining topics that we need to know, the remaining topics that we need to finish today. And we just need to know actually the basics. We don't have to go deep on each topic because this is just an introduction. We'll go through every single topic later in details on the coming videos. So let's start the first topic, which is wide area network. So basically this is like the internet. Okay, when you connect a network over large geographical areas, you can just assume this is like the internet. Okay, when you're inside a private network, when you want to go through the internet, you're basically going to the one. Okay, that's the basic meaning. So spine leaf, it's just an architecture used in data centers, big data centers, okay, like Google or other data centers. Okay, this is how they structure they design their systems. We have two types: leaf switch and spine switch. Basically, leaf switch connects to the server, okay, and spine switch connects to all the leaves. Okay, I have a diagram. I'll show you. Let's go to the picture here. We have spine leaf. Yeah, this one. So this is basically what I mean by spine leaf. Okay, spine leaf data center network architecture. Here, this is the spine switches. These are the switches that are on the called spine switches. It's more powerful usually than the leaf switches. And this is the leaf switches. Okay, those leaf switches, they connect. They're responsible for connecting to all the spine switches. Okay, make sure that it's all connected in a mesh network. Okay. And make sure it's connected on a mesh network, and the leaf switches are connected to the server. So this is a spine leaf. And the other type, we have two-tier architecture and three-tier architecture. Okay, and the difference is that the number of layers that we can add in the switch. Like for example, this three-tier architecture. Okay, we have here the core switch. Okay, this is the main switch, and we have here the aggregation switch and access switch. Sometimes they can be combined into one collapsed layer. Okay, and then this is the server. Okay, so basically you can consider this two as one. Okay, so this first layer is core switch, and this two will be considered as one. And this is the server, third layer. Okay, so this is the difference. So we have also two-layer switch, two-layer structure, two-layer architecture, two-tier architecture. So this one is a two-tier architecture. So this is collapsed core. This is the backbone, and this is the access layer. Okay, so basically this is the two-tier architecture. This is cheaper and less expensive than the three-tier architecture, but the three-tier architecture is actually better for scaling. Okay, that's the main benefit, and that's why it's used by much larger organizations. SOHO, small office, or small network with router, switch, Wi-Fi access point. This is limited. This is a small network. Like in your home, for example, you may have an access point, and you may have one switch and router like this modem. Usually, it's a modem, the router from the ISP, and that's what we call small or home office and home office. And on-premise versus cloud. On-premises hardware owned and managed locally. Okay, this is on-premises. Like let's say we have let's say we have servers. We have a company. Okay, they're using their own servers. Okay, they have a system installed on this server, and they're sharing it to their network privately. So they're using the system from the server. So this is called inside the server is located inside their property, right? This is an on-premise locally, and cloud hosted. However, it's different by provider. It's hosted by the servers. All this is hosted by the cloud hosting provider. The most famous one is AWS, and then we have Azure and Google Cloud as well. Okay, the benefit is that cloud offers scalability and lower upfront cost. Okay, it's cheaper. Like the upfront cost, it means like if you will have an on-premise hardware, you will have to buy the server, right? And you will have to install the system, Windows server. Even it will cost you a lot of money. Even the software, the operating system, even the hardware as well. And all this installation cost, maintenance cost, all this will be expensive. So, but this, however, the cloud, you don't have to pay anything. You just have to pay for the service you use. And physical interface and cabling. Physical interface and cabling. This already we discussed, so we're just going to get the basics. So copper basically it means the internet. Ethernet, this is what we talked about. The distance is less than 100 meter. Okay, the speed is up to 10 gigabits based on the CAT version. We have CAT 5 and CAT 6. It's cheaper and it has less resistance to electromagnetic interference. Okay, that's the difference. And fiber, however, it has excellent electromagnetic interference, multi-mode and single mode. As we discussed, multi-mode travels lesser distance than the single mode. Single mode can travel up to 100 plus kilometer, and multi-mode just to 550. The speed is higher also in multi-mode, but no, in single mode the speed is higher. The cost is higher as well, single mode and multi-mode. We have connections RJ45, copper, Ethernet, and we have fiber optics. These are the RJ45 is a connector that's used to terminate the Ethernet cable. Let me show you how it looks like in case you're not familiar with it. Now, so this is RJ45. These are the connectors. So just like I told you before, we can use, for example, this 1568B standard. Okay, this color code of the wires, and put it inside the connector and terminate, so the cable will work. And SC is also is used as a connector for fiber optic. SC. This is it. So we can check the difference between the connectors and to see the comparison. SC patch cord, LC patch cord. So this is LC, SC patch cord. This is how it looks like, and this is how LC looks like. So yeah, SFP module. This is a SFP module, modular transceiver. Modular transceiver. Okay. Modular transceiver. So this is actually this is used to connect free switch. This is a module that you put it inside the switch here, and we have here a PoE, supplies power over data over Ethernet. This I already discussed in the previous session. This I already discussed in the previous session. So let's talk about the damaged. Okay, these are the issues. That the cable could be damaged, for example, and you could use like a wrong cable type. Okay, yeah, if you can use the wrong cable type, like speed and duplex mismatch, loose connectors, and incorrect pinout, straight versus crossover. And all this we can discuss it. Like straight versus crossover is like when you want to connect, like for example, if the two similar devices, and when you want to connect different endpoints. That's the difference between straight and crossover termination. So one will use the same standard on both ends of the cable, and one will be using different standard. Straight through versus crossover. It's different standards for two ends. So this is basically the difference. Straight over and so basically this is what's going to happen. Yeah, this is straight through. Straight through means this one. So basically on both ends you'll use the same arrangements of the cable. Like for example, you'll use here white orange, and orange white green, blue and white blue, green white black, and black, right, on this side of the end of the cable. On the other side also you'll use the same. This is straight through. This is the meaning of straight through. The same standard you're using on both ends. The same arrangement of the colors you're using on this both ends. Crossover, however, you're using one end, one arrangement for one end. The other end you're reversing it. Like you're using another standard. Look, this one, pin 3, pin 2. White green, green, white orange, brown, white brown, green. This is the main difference. Okay, and usually this is used for example, if you have this, if you want to connect two of the same devices, I think you have to use as shown here, same devices. Yeah, let me show you the differences here. So this is the difference. Let's say you have two switches. You want to connect from switch to the router. Okay, you have to use straight through cable. You have to use straight through cable, right? Same standards. Okay, let's say you want to connect the switch to the PC. You have to use the same standard. You want to connect switch to the server. You have to use the same standard. Switch to the PC, same standard, same color code, like 568B standard. We can use on both ends. You don't have to change. However, in crossover cable is used for similar endpoints. Like for example, if you want to connect two different switches, two same switches, you have to use crossover cable. Two switches, you have to use crossover cable. You want to connect two. two routers or two switches, L2 or 3 switches, you have to use the same two routers. Also, you have to use this crossover. And from router to the PC, you have to use crossover also. Two PCs crossover as well has to be used. So basically, this is it. So most of the time you'll be using straight through cable. Okay. So unless you have interconnections like two different routers or two different switches, you don't need to use this one, straight through cable. So that's the idea. And IP addressing and subnetting. So basically, this is a way of subnetting and dividing networks into smaller networks. Use a subnet mask. And yeah, we have IPv4 32 bits. So we'll have a separate video for this IP address subject. So we can skip it for now. But it's a way, you just have to understand that it's a way of dividing networks into smaller networks. Need for private IPv4. Yeah, this is the private range. Okay, the benefit of having a private range is that you can have as many IP addresses inside your network locally. Okay, public address IPv4 address, however, they are limited. Okay, that's why they use it in only to go out to the internet. Okay. Yeah, due to the limitation of the public IPv4 addresses, they've created IPv6 addressing scheme, which has more addresses available. Okay, so no need NAT also. Yeah, NAT is basically a way of converting this private IP addresses to public addresses, to single or multiple public IP addresses. That's the benefit of NAT. Okay, like if you think about it, let's say you have an IP of 192.168.0.1.16. Okay, you're inside your network, right? But the modem or the router will be the default gateway, which will be 1. Okay, and then to convert it, so the modem, what it's doing is it's converting the private IP address to the public IP address. Okay, and all this we can discuss it later. IP address subnet mask. Okay, this the difference between IP address subnet mask and prefix default gateway DNS server. Let me show you what's the meaning of this. Let's say 1 second. Okay, let's just assume we have here. Okay, so basically this is the IP address of this device. For example, 192.168.1.200. Here I can change it as well. This is the subnet mask. Okay, this is the default gateway. Like if you want to get out to the internet, you have to mention the default gateway, because this right now is internal. It will work internal locally, but it will not work. It will not take you outside the internet. This is the DNS server. And yeah, and Wi-Fi we already discussed. 2.4 gigahertz. We have 1.6.11, many or non-overlapping channels. Prevent interference, improve performance. This already we discussed about this. One physical machine runs multiple virtual machine. Uses hypervisor 1, 2, 3. Yeah, a virtual machine is basically a way to run. Let's say you want to run Linux operating system on your PC. Okay, so what are your options? Like you can format the entire, install it, and remove your old Windows, and install the Linux operating system instead, right? It's one option, but like there is another option. We call it hypervisors, type 2 hypervisor. Like it's a way to run another operating system inside your existing operating system. Let me show you how. VMware is one of the top virtual machine providers available. So okay, this is now Kali Linux. Okay, I have it on this virtual machine. I can power on, and it will take me to the virtual machine while I'm still inside my Windows. You can can see this one. Okay, so this is basically what a hypervisor is. It's a way to run another system. Benefit is, of course, it will have its own IP address, and it will have its own storage. You can specify the resource also, how much resource to consume from the actual. That's the difference. And type 1 is, however, is different. Type 1 is bare metal hypervisor. This is like ESXi. 1 second. You have to install it in ESXi. 1 second. So this is like, for example, this one. Okay, you will install hypervisor. You will install this one on the bare metal. Okay, of the operating. There will not be an operating system inside that one, inside the hardware. Type 1 versus type 2. Type 2 hypervisor. So this is the difference. Type 1 hypervisor, you have a hardware and you have the hypervisor, that's it. And you can add the VM, as much VM as you want. Okay. However, in type 2 hypervisor, you have the hardware, okay, like this one, this is my laptop, and we have the operating system like this one, this Windows, this is my Windows, and we have the hypervisor, this one, this is my virtual machine, right? Right now I'm using type 2, right? But if I want to use type 1, I have to buy a dedicated hardware, like a server or something, and install the hypervisor, okay, like VMware ESXi, and I will install as many VMs as I want inside this hypervisor. So this is the difference. The difference is there's no operating system installed on the hardware. Efficiency, isolation, scalability. So switch, okay, the difference, the switching concepts, okay. We have here MAC learning. So basically this is what switch does. Okay, switch learns MAC address from incoming frames. Okay, so basically whenever we try to do anything on, let's say I visited Google, or I tried to ping or do anything in the network. Okay, so basically since I'm connected to the switch, it will go, the data, the packet will pass through the switch, right? So what happens is the switch will keep it on, will keep the record in its MAC address table. Okay, and that's what it uses to forward frames, like here. Okay, it has a MAC address table. Okay, it will take my MAC address. That's how it can identify me. Okay, that's how it can identify me. Then it will remember next time as well. So this is MAC learning. This is how it works. Okay, and frame switching, we have used this MAC address table to forward frames. Okay, this is, yeah, just like I told you, the switch uses the MAC address to forward the frames. Frame flooding, unknown destination sent out to all ports. Yeah, this what it means basically is that let's say the switch, let's say this is the first time I'm talking to the switch. Okay, so here's what happens. It doesn't know. I want to go through another PC. Okay, I want to send my packet to this specific PC or this specific. So the switch doesn't actually know. Okay, this doesn't have the data inside the MAC address table, right? So what it will do, it will send all. It doesn't know which port this device is connected to. So it will send out all the ports except the source, and then it will be able to know which one is this. MAC address table, this is the table. Maps MAC address to switch port. Is the main thing that you need to know right now. Maps MAC address table to switch port, updated dynamically. So let's see if we have packet tracer here. I can show you once and then we can conclude. Let's download packet tracer. Okay, because you have to also download packet tracer because we will use it in our in our session. So you can download it here from here. Or better, let's download from the official website. Yeah, this is okay. Cisco packet tracer. No, let's see. What's the reason here? Maybe. Now available for download, but it's not downloading. Let's see where we have Cisco packet tracer download. Yeah, this one. This could help us to download Cisco packet tracer. Okay, so basically this is what I will do. I will put it inside yeah, I will post the link. Okay, so for the next session you have to have Cisco packet tracer on your PC. I will share the download link. Okay, I will check it and then we'll discuss further on those topics. Thank you for watching, and don't forget to subscribe and comment and all that. Thank you. Bye. See you on the next session.